everyone. We're back again with another. This time, this won't be a laboratory exercise, but it's a preliminary examination. So since I haven't passed the oral examination, so I'll be providing the preliminary examination, more like a removal. So let's proceed right away. So I'll be reading only the instructions. So for the part one, foundational understanding, explain what a design pattern is, describe its purpose in software development, and why developers reuse patterns instead of creating solutions from scratch. So explain a design pattern. Design pattern is like a reusable template or solution that helps solve common problems in software development or in programming. So an example for that is a strategy pattern in which you only have to implement it once, and then you can reuse it later by choosing different strategies in different scenarios. So that's just a very basic and common example. So for the second question, differentiate the three main categories of design patterns: creational, structural, and behavioral, and give one real world analogy for each. So um, there are creational, structural, and behavioral patterns. So for the creational patterns, they focus on how objects are uh, created and uh, controlled in some way. So real world analogy is ordering food in different ways. So you can cook at home, buy fast food, or order online. So there are a lot of ways for that. And then for the structural patterns, this is these are patterns who deal with how classes and objects are combined to form bigger systems. So it structures the overall system into a bigger uh, into a whole new bigger system by incorporating and integrating a lot of microsystems and objects and classes. So yeah, uh, uh, what we call that, the real world analogy for that is using an adapter plug for the extension wire. So for this, if you have an adapter for this, so that would be the real world analogy for the structural. And then for the behavioral, we have these behavioral patterns are let us know how objects interact and communicate with each other. So real world analogy for this is that a teacher sending announcements to students, um, or a an influencer posts a video or content on Facebook or YouTube, and then you as a subscriber will be notified along with all the other subscribers. Okay, so let's proceed to part 2, creational patterns in action. Choose one creational pattern, singleton, factory method, or builder, and explain the problem it solves. Simple diagram, scenario in software. So uh, for the part 2, we have it says here that we have to choose our creational pattern. So I'll be choosing singleton, and I have I have the so first, let's state the problem it solves. Sometimes in a program you only want one instance of a certain class, such as the previous laboratory activities in which we have created the game asset generator. So yeah, singleton design pattern was applied to that specific activity or system. Then we have simple diagram. This is just a simple diagram, if you can see. Okay, so we have singleton class here, and then has an instance and then get instance attributes. So it stores the single object, returns the same instance, and always returns the one and only object. So if you have a program like a game asset generator, so you must apply a singleton design pattern in which you uh, only must have a single instance of the game running in order to prevent anomalies and other issues that may not suit the game. Okay, so scenario in software, it fits normally. So a perfect example for this is an application logger. So the logger writes messages to a single log file, and then if the program uh, created 5 different logger objects, then the log file might be corrupted or mixed up. So using a singleton logger ensures that the whole application writes to the same file, so using the same instance. So that's what I have said or mentioned earlier. So many explain at least one benefit and one potential. So a benefit of the singleton design pattern is that it gives you controlled global access point. So meaning the whole program can share the same important objects, features, and without accidentally making or creating duplicates. And then its drawback is that these patterns, singleton patterns, can sometimes make a highly and tightly coupled system. So because many parts of the program may depend on a single instance, so that is a con of this design pattern. So structural patterns part 3. Imagine you're improving messy system. Explain how adapter pattern can rescue the system. And then give a before after. So, sometimes different classes were made at different times and they do not match each other's method. So such as working in a group. So that's the best example. Okay, so explain how adapter pattern can rescue the system. So let's say um, we have functions for React Native. We have functions old printer, new printer, and system expects. So we have print text for the old printer function, and then we have another print document for this new printer function, and then the system expects with the print uh, function. Okay, so um, but we want to execute the print function on all of these. I'm sorry, old printer, new printer, and system expects are objects and not patterns, or they could be classes in Java. So please bear with me. So let's say they are objects, and then we have let's just say that they are objects, and we want to use the print method. So I'll just show you the diagram here. We have say this is the system, and then we have the printer adapter here at the center, so you can see. So if we use the same print methods, since old printer uses print text method, then a new printer uses print document method. So in order for them to have a workaround, we'll be using a adapter. So for this one, we have a printer adapter which we have set a method of print for compatibility concerns. And yeah, so this is for the old printer and the new printer. So with that adapter, they can both work together seamlessly and integrate two systems into a whole um, upgraded system. So compare the adapter pattern and the decorator pattern. So adapter pattern makes incompatible classes work together. So that's what I have said. From the diagram, the old printer and new printer. So yeah, and for the decorator pattern, it adds extra behavior to an object without changing its original class. Okay, so let's proceed to part 4. Present a scenario where objective pattern is excuse. So scenario objective pattern is necessary. So objects communicate without. So we have here scenario. Present scenario where objective observer pattern is necessary. Imagine a delivery tracking system. When the delivery updates, the status like out for delivery, several like when the system updates the status like out of delivery, several parts of the system must react to the customer app, the admin panel, and the notification service. The observer pattern allows the observer pattern allows all these parts to automatically update without being tightly connected. So I have a diagram here again for the observer pattern. We have a observer delivery status subject here that notifies observer A, the customer app, observer B, which is the admin dashboard, and then the notifications for the observer C. So the subject delivery status communicates with all three of these servers. So in order for the app or the system to work appropriately and real-time updating each um, required server for these app. Okay, so choose any behavioral pattern, strategy command, or iterator. So I'll be using the strategy since I'll be choosing the strategy since I'm the one who have reported it. Strategy pattern. Let's use swap different algorithms without changing the main code. So as I have said earlier, we can reuse the strategy pattern by applying the same method but different strategies for different occasions or concerns or different scenarios. Okay, so let's proceed to part 5. Assume you're designing online identify two design patterns. Assume you're designing an online delivery system and identify two design patterns you would apply and explain why they are appropriate. So for the two design patterns, I'll be explaining the observer and the factory method. Uh, for the delivery system, useful for order and tracking status notifications, that would be the observer pattern. When the order updates, all waiting components such as the customer, restaurant, admin will receive automatic updates. And for the factory method, helpful it is very helpful for creating different types of users such as driver, customer, or admin, and then generating various orders types such as delivery order and pickup order, etc. So those are the two main or very appropriate patterns for the delivery system. And then for the number 10, evaluate this claim using many design patterns always makes software better. Agree or disagree, depend. So for this instance, it might be a little bit in between, but for me personally, I disagree because patterns they are indeed helpful, but using too many or using all of the design patterns, it doesn't always makes software better. So it might be it could be it could make the software better, but it doesn't make the software better always. So it could be sometimes or oftentimes or in some scenarios. So um, these patterns are indeed helpful, but using too many hard code can make code harder and read can make code harder to read and understand. So especially for simple problems. So for simple problems, you don't have to exaggerate on creating a lot of design patterns, implementing a lot of design patterns for that. So because it would make our system exaggerated and unnecessarily uh, crowded, or what do you call that, very not specific to its ideal use or ideal purpose. So for this preliminary examination, this will be it for the video, and I hope you have understood and liked this video. So thank you and have a great day ahead.